Okay, example 1. We have 2x plus y plus z equals to minus 1, 3y plus 4z equals to minus 7, and 6x plus z equals to 8. Okay, so what I'm trying to do is make any two variables in terms of the third variables. For example, y and z all in terms of x, and I can put all of those informations in one equation, and I can just solve for x, one variables. Let's name this 1, 2, 3. There are a lot of ways we can do those questions, but like we think about easier ways of doing this. So first of all, let's think about if I want to put x, y and z all in terms of x. So I will start from the third equation, right? I'll start from the third equation. So I will rearrange, let's write it here. I'll rearrange number 3. I'll have z equals to minus 6x plus 8. Okay, z equals to minus 6x plus 8. This is already good because z already in terms of x. Okay, and now let's rearrange. Let's give this number 4 and rearrange number 2. Okay, when you rearrange number 2, so 3y will equals to minus 4z minus 7. Y will equals to minus 4 over 3 z minus 7 over 3. Okay, now y is in terms of z. Let's say that's number 5. We can sub number 4 into number 5. Okay, we can sub number 4 into number 5. What will we have? I'll have y equals to minus 4 over 3. What is that? Z is minus 6x plus 8 and minus 7 over 3. So y will equals to 8x minus 32 over 3 minus 7 over 3. So times 2, so it's 8x and minus 32 over 3 and minus 7 over 3. So it's minus 39 over 3, so which is 8x minus 13. Right? 8x minus 13. And let's say that's number 6. Okay. So now I haven't do anything to first equation yet. So I will substitute everything into the first equation. I'm not going to substitute things back in the second or the third equation because I have already used up all this information. I want to use a new equation to solve for that. Okay, so I will sub number 4 and number 6 into number 1. Okay, all the things in terms of x. So 2x plus y, what is y? Y is 8x minus 13 plus z, what is z? Z is minus 6x plus 8. That equals to negative 1. So 2x plus 8x minus 6x minus 13 plus 8 plus 1 equals to 0. So I have 4x plus 9 minus 4 equals to 0. So 4x equals to 4, x equals to 1. Okay, x equals to 1. So remember to solve other things as well. So sub x equals to 1 into number 4, you will have, let's sub into number 6 first. So you will have y equals to 8 times 1 minus 13, y equals to minus 5. And sub x equals to 1 into number 4, you will have z equals to minus 6 times 1 plus 8, and z equals to 2. Okay, so what we have is those three solutions. Okay, so for two equations, what we have done is just put x in terms of y and sub that back. So now for 3 equations is the same. Okay, for 3 equations is the same. Okay, for example 2. For example 2, x plus 2y plus 3z equals to 13, minus x plus 3y plus 2z equals to 2, and minus x minus 4y plus 7z equals to 17. So everything we will have x or y. Okay, everything we contain x and y. X, y, z, 3 variables. So it's not like as simple as the first one. So what we can do is just do it step by step. Okay, do it step by step. So for the first one, okay, for let's say number 1, number 2, and number 3. Okay, so what we can do is, first we can add equation number 1 and number 2. Why are we adding them? Because we can eliminate one variable. Okay, we can eliminate one variable. So we have 5y plus 5z equals to 15. So y plus z will equals to 3. Okay, and z will be minus y plus 3. Okay, that's equation number 4. Okay, let's sub number 4 into number 1. Let's see what can happen. We can have x plus 2y plus 3z. 3z is this. 3z is this. And equals to 13. And we have x plus 2y minus 3y plus 9 equals to 13. And we have x minus y equals to minus 9, that's 4. Okay, x minus y equals to 4. And y equals to x minus 4. Right, y equals to x minus 4. That's equation number 5. Okay, so your z is in terms of y and your y is in terms of x. Okay, I want everything in terms of x. So I will sub equation number 5 into number 4. Okay, sub equation number 5 into number 4. So if you put 5 into number 4, z will equals to minus x minus 4 plus 3, z equals to minus x plus 4 plus 3, and z equals to minus x plus 7. Now you have y in terms of x and z in terms of x. Let's say that's equation number 6. So I will sub 5 and 6 into the last equation because I haven't used the third equation. So everything put into equation 3. So I'll have minus x minus 4y. So it's 4 times x minus 4 plus 7z. 7x minus x plus 7 equals to 17. So minus x minus 4x plus 16 minus 7x plus 49 equals to 17. Okay, so we have that, and we have this, and this. So minus 5, so it's a minus 12x plus, that's 5 and 65 and 17. So 65 minus 17 equals to 12x. 48 equals to 12x. X equals to 4. Okay, when x equals to 4, So sub x equals to 4 into number 5 to solve for y. So y equals to 4 minus 4 is 0. Okay, y is 0. So sub x equals to 4 into number 6. Z equals 2 minus 4 plus 7 is 3. Okay, so we have x4, y0, and z3. Okay, like it's pretty long. Okay, for this type of question, it's pretty long. But like it's quite easy. It's quite easy. You just think about what can happen for everything. Okay. Okay. Any question about this? How we can solve 3 variable simultaneous equations? Okay, then let's have a think about what can happen for 3 linear equations. For 2 linear equations, okay, for 2 linear equations, what we can have? Like 2 variables have parallel, coincide, and intersections, right? 3 different cases. But for 3, like it's 3D dimension, right? We have x, y, and z. Okay, x, y, and z. So 3-dimension thing. What can happen? So it's talk about like a surface plane. So they can intersection only at a point. So what we have solved out is all intersection at a single point. Just like the first diagram. Okay, they somehow like you can think about the 3 pieces of paper and try to intersect at one single point. Okay, that's the first case. For the second case, okay, they will have a unique solution for this one. Okay, the intersection at one point is a unique solution. Okay, for this one, they can intersection in a line. If the intersection in a line, what that means? Infinity solutions, and it's a linear solution. Okay, for example, y equals to 4x plus 1 is a linear solution. Okay, so it's intersection at the line. Or absolutely no intersections. Okay, what means absolutely no intersections? If they're all parallel to each other. Okay, if they're all parallel to each other, like 3 surfaces like face parallel to each other. There's no solution. And for those 2 are all no solutions. Okay, 2 and 2 can intersect between 2, but the third one cannot intersect with that. So for this case, diagram number 4. Let's think about diagram number 4. Okay, if you think about diagram number 4, which means you have 2 parts already parallel. If like 2 things already parallel, no matter how the third one acts, like never got the solution, right? It's already parallel. You cannot intersect between those 2 already. So the third one cannot be intersect for sure. Okay, so we use this idea to solve next question. It's kind of extension question. I never see it really in exams, but like there's a concept on the book, so we better go through that. Okay, understand what's talking about. So now I want to consider the following system of linear equations where n is a real constant. Are there any set of n for which the equations are inconsistent? What means by inconsistent? What's inconsistent? No solution. Remember, inconsistent means no solutions. And the next part is asking, are there any values of n for which the equation have an infinite set of solutions? Have an infinite set of solutions. So, which is the diagram number 2? Okay, which is the diagram number 2? They all intersect at the line. Okay, so it's very similar to what we can think about for 2 linear equations. Okay, for 3 variables, we want to reduce it to 2 variable equation first. Okay, so how we can reduce that? Let's think about equation number 1, equation number 2, and equation number 3. Okay, think about equation number 2. I only contain 2 variables, y and z, right? Y and z. I can't solve 3 variables at the same time. I will reduce it to 2 variables first. And think about what can happen between those 2 variables. So let's do something to equation number 1 and number 3 and eliminate the x, right? I only want to have y and z to think about first. So I will times number 3 by 2. Okay, I'll times equation number 3 by 2. What I will have is 2x minus 4y plus 2z equals to 1. Okay, let's say that's equation number 4. Okay, let's see equation number 1 to subtract equation number 4, because we have 2x and 2x, subtract that. So we have m plus 3y subtract minus 4y minus m plus 4z subtract 2z equals to 0. Wait, I forgot to times 2 here. That's a 2. So I have a minus 1 here. So 1 is to times by 2 as well. Okay, constant times by 2 and have negative 1 here. 1 minus 2 is negative 1. And now I will combine the similar term, that is m plus 7y minus m plus 6z equals to minus 1. Okay, so y will equals to m plus 6 over m plus 7z minus 1 over m plus 7. Right, if I make that into the gradient intercept form, we can move that to the side and divide m plus 7. And let's rearrange equation number 3. Not equation number 2. Okay, that one only contain y and z, so y will equals to minus m plus 4 over 2z plus 1. Okay, so what's the gradient? That one is the gradient. That one is the intercept. That is the gradient. That is the intercept. So let's solve for 2 gradient to be equal first. It's like the same idea. Like if I already cannot find any solutions for y and z, how we can find solutions for x, right? Right? Is that the reason? Like if I can find a particular value for z and a particular value for x, y, I substitute back to any equation, I can work out what is the x value. If y and z are a particular value, x must be a particular value, right? But like if you already have no solutions for y and z, there won't be any solutions for x, right? Okay, so that's the logic. Okay, that's the logic. So if you solve for gradient, m plus 6 over m plus 7 equals to, that's minus, that's a 4, m plus 4. So it's a minus m plus 4 over 2. Okay, I'm trying to solve for that. I'm not bothering to solve it by hand. Actually, I have no space. Actually, like we should do this by hand, but let's do it by CAS. Okay, so add the calculator. Menu number 3, number 1 to solve. And we have x plus 6 over x plus 7. That equals to minus bracket x plus 4 over 2. comma x. Okay, x equals to minus 8 or x equals to minus 5. And plus 6. N equals to minus 8 or n equals to minus 5. And now I want to solve for this. C1 equals to C2. So minus 1 over n plus 7 equals to 1. Minus 1 equals to n plus 7. N equals to minus 8. Okay, n equals to minus 8. I should put it here. Minus 1 over n plus 7 equals to 1. N plus 7 equals to minus 1. N equals to minus 8. Okay, now for solving x and y. Okay, for solving x and y. Let's think about this. We want to solve a value. If I want to solve x and y to have one value, okay, any value, they just need to be not parallel, right? For the z and x variable, they just need to not parallel. I can solve out x and y because for equation number, okay, let's say that's equation number 5 and this is equation number 6. For equation number 5 and number 6, they are two linears. Okay, they're just two linears. Change z to x, you just solve x and y. Okay, it's two linear. For two variable linear, if I want to have a solution, I just need the gradient not to be equal. Okay, just the gradient not to be equal. So if n not equal, n belongs to R, except minus 8 or minus 5, there will be unique solution. Okay, there will be unique solution. Because if I can solve a particular value for z and for y, sub back, I must have a particular value for x. It's a one-to-one relationship, right? If I have x, I have z, I must solve out x by a particular value. Okay, now let's think about if n equals to minus 5, which give you the gradient equal, but C1 not equals to C2. Okay, C1 not equals to C2, right? If C1 wants to be equals to C2, n must be negative 8. But n equals to negative 5 can only give you gradient equal, but different y-intercept, which means y and z have no solution. So, no solution for x, y, and z. Therefore, no solution for x. Therefore, it's inconsistent. Okay, it's inconsistent. It's an inconsistent case if n equals to minus 5. Because if I cannot have any value for y and z, how we can find values for x? This thing just not going to work. Okay, the last one is n equals to minus 8. Okay, if n equals to minus 8, there will be infinitely many solutions. Why there will be infinitely many solutions? N equals to 8 give you two gradient equal and C1 also equals to C2. The C values equal. Okay, give you the same gradient and same y-intercept. Which means, okay, y and z have infinitely many solutions. Y and z will have infinitely many solutions. It's a late alarm. Okay, it's an infinite many solution between y and z. So what's the equation for y and z? Let's sub n equals to minus 8 into equation number 6. Okay, equation number 6. So y will equals to, okay, minus 8 plus 4 minus 4. 4 divided by 2 is 2, so it's equals to 2z plus 1. Okay, this linear is 2z plus 1. Okay, y and z, the relationship between y and z is 2z plus 1. If it's 2z plus 1, any coordinates on this will be the coordinates for y and z. So let's let z equals to alpha. Then y will equals to 2 alpha plus 1. Okay, that's what we have learned yesterday between y and z. Let's sub this into, okay, sub z equals to alpha and y equals to 2 alpha plus 1 into the third equation. We will have, okay, x minus 2y plus z. Okay, x minus 2y is 2 alpha plus 1 and plus z. Plus z, z is alpha, right? Plus z, z is alpha. That equals to what? So x equals to x minus 4 alpha minus 2 plus alpha will equals to what? Then x will equals to 3 alpha plus 3. Okay, x will equals to 3 alpha plus 3. Put the 4 alpha that side, minus alpha is 3 alpha, minus 2 add to the side is 3. So 3 alpha plus 3. So the infinitely many solution will use perimeter to represent is 3 alpha plus 3, comma 2 alpha plus 1, comma alpha. Okay, that will be infinitely many solutions on this set. Okay, on this set. And alpha can be any number. Alpha can be any number. You just change the number for alpha and you will have different set values for x and y. And that's using perimeters to talk about the number of solutions. Because still three different cases. Intersect at a single point, no solutions, and they can intersect as infinitely many values using parameters to represent. Any questions? Question? No? Yeah.